Okay, we're on lesson 2-3, and I am on page 98 in your book. Remember, whatever I underline or highlight, I would like for you to please underline and highlight. And so we're going to talk about how we can use the distributive property here to solve multi-step equations. And what I just want you to remember is that we've practiced with the distributive property. It was one of our skills that we practiced many weeks ago, and we're going to continue practicing with it. And then I also want us to remember our steps to solve. If we look at example 1, it looks like a lot, okay, but they applied the distributive property to solve this multi-step equation. And again, I just want to remind you that we can go through our steps each time, and that will help us be successful in solving. So let's go over those steps, and then we're going to go ahead and jump into this try it at the bottom. And remember, when we look at this try it, Mrs. Bora is not a fan of those boxes. I think they can be more confusing than helpful. Put a piece of paper over it, a note card, a sticky note. Okay, so let's talk again. And I've added a little bit here, thanks to Mrs. Silveri and Mr. Burkett, to maybe hopefully clarify some things. Here's our solving steps. That should be a plural. There's more than one. Draw a line down the equal sign. Change all subtraction to addition, and apply the distributive property. Those are the first 3. Number 4 would start to get a little confusing. We want to combine like terms, and we are looking at the same side of the equal sign. Okay, the same side when we do that. And then I have the line, because I want you to think of that line as now we're moving about the line. We're going to start to move. The first thing we need to do is we need to get our letters together if they're not. And then we're going to do those inverse operations to isolate the letter and get it all by itself. So let's just jump. These are our 5 steps we're going to go over. Again, remember, if we were in the classroom, these 5 steps would be on a poster, and we'd be referencing them every single time. Put them on a sticky note. Have them next to you. Let's jump right into this try it. And again, remember, I'm not a fan of these boxes. I'm going to rewrite this problem. We have 3 open parentheses, x take away 5, close parentheses, negative 5x equals negative 25 plus 6x. Okay, this looks like a lot. Let's not be afraid of it. Okay, let's tackle it step by step, and I bet you'll see you can be very successful with it. Draw the line down the equal sign. You have successfully taken care of step 1. Okay, step 2, we know, is change all of our subtraction to add the opposite. So I'm just going to put plus negative 5 there. I'm going to make this a plus and a negative 5. Step 1 and step 2 are done. Now we need to apply the distributive property. Yes, I have the distributive property here because I see the parentheses. The number in front of the parentheses is going to be distributed to everything inside. That's it, inside the parentheses. So you'll notice I only have 2 arrows because I only have 2 things inside my parentheses. If it's not written, remember that the number in front of our x is a 1. So if I take 3 times 1, I get a 3x. Bring down that addition symbol. If I take my 3 times my negative 5, I get a negative 15. And then I'm going to just bring everything else straight down. Plus negative 5x equals negative 25 plus 6x. Remember, we are only multiplying by what is inside the parentheses. Step 4 is where we are looking to see if we can combine anything on the same side. So let's just look at this left-hand side. Do I have like terms on the left side? Yes. We do. We can combine our 3x and our negative 5x. They both have the letter x. So we know 3x's and a negative 5x would give me a negative 2x. Bring down your plus negative 15, and everything else comes straight down. Was there anything on this side that I could combine? No, because they don't both have the letter x. So now I'm to that step 5 where it's the move step. And the first thing you want to ask yourselves are your letters all together? No, they're not. So we need to get them together. And I want you to think about what is the smallest one. Is -2 the smallest, or is a +6 the smallest? We like to move the smallest. And my -2 is. So I'm going to do the opposite of a -2x. I'm moving the entire term. So I'm going to add 2x. And whatever I do to one side, I do to the other. The reason is we have 0 here now. That is a big old 0. We bring down our -15. We have a -25 plus an 8x. Now you got your letters together. So now we need to undo our add and subtract. Get that 25, it's a -25. So the opposite of a negative would be add 25. Whatever I do to one side, we need to make sure we do to the other. The reason we did this is because this is 0. And I now have 8x on the left is equal, -15 plus 25 is going to be, excuse me, a +10. I apologize, Mrs. Bohr is running out of room. I'm going to go over here to the side. So we have 10 equals 8x. All I did was rewrite that. I have one last step. How do I get the x by itself? I'm now breaking apart the 8 with the x, and the inverse of this multiply would be divide. So our final answer here would be x equals 10/8. It's an ugly fraction. We can just leave it like that. In class, we'll talk about how we could simplify those fractions, but just leave it 10/8. It is improper. We can change that. Again, in class, we'll talk about how we change that. Let's go ahead and look at our next slide. And what I really want us to be careful with if we're looking at example 2 is it says that we are distributing the negative. Okay, when we distribute the negative, especially if you look at example B, my suggestion, as I zoom in here, and this is why we want you to change all subtraction to add a negative. So remember, if there's no number in front of a letter, we write the number 1. Well, if there's not a number in front of my grouping symbols here, I can put a number 1 there. It means one group. And if I were going to rewrite this problem, and remember what I write on my paper, I'd have you write on your paper. If I was going to rewrite this problem, I would write it as 3 plus a -1, x plus a -3 equals 25. Because remember, we want to change all of our subtraction to add the opposite, to addition. That is why we have that step in there, step 2, change subtraction to addition, so that we're careful with these examples. The third example, and you can pause, rewind, rewatch this. Okay, make sure you get everything written down. My third example just has the distributive property on both sides of the equation. That's okay, you can handle distributive property on both sides. This is kind of a yucky one with all the fractions. I'll give you some fractions, but mostly like a half. Okay, so let's look at our very last try it before we look into practice. And our last try it is on the bottom of page 99. Oops, excuse me. There is a fraction here. Okay, but it's not that bad of a fraction. There's no boxes, thank goodness, because I don't like them. So let's go through our steps. Draw my line down the equal sign. Lots of subtraction I want to change to add the opposite. Well, this is already a -3, that's already a -7. I'm going to just rewrite it. The minus x we can put as plus a -1x. I'm going to put the 1 in front. Bring down the 1/2, my x plus 2. So I changed all my subtraction to addition. We do have the distributive property, and this time we just have it on both sides. It just means we're doing it twice. You guys know how to do the distributive property. My -3 needs to go to everything inside the parentheses on that side. -3 and -7 is a positive 21. A -3 times a -1 is a positive 3x. 1/2 times x, we'll just think of that as a 1. It's just 1/2 x. And what's half of 2? The whole number 1. So we distributed the -3 to everything on the left side that was in the parentheses, and we distributed the 1/2 to everything that was on the right side in parentheses. Now, do we have like terms? Do I have like terms on the left here? Do they both have an x? No. Do I have like terms on the same side over here? Do they both have an x? No. So we need to move. We want to get our x's together first. Let's get those letters together first. And is 3 or is a half smaller? Well, think of a half of a dollar as smaller than $3. So let's move the half first. The opposite of 1/2 x is a takeaway 1/2 x. Remember, we're moving the entire term. The x is going with it. The reason we did that is because this is 0. Bring down 21. What is $3 minus a half a dollar? We would have 2.5 x equals 1. Now that we got our x's together, we still need to move to undo all these operations so that my x is all by itself. So the inverse of that positive 21 there would be we need to take away 21. Whatever we do to one side, we do to the other. Why did we just do that? So we get 0. We have 2.5 x equals, and 1 minus 21 is going to be a -20. We're going to keep going. We have 2.5 x. There's a couple different ways to go about this one. A couple different ways. We know 2.5 times x. That's a times, and we want to get the x by itself, so the inverse could be that we divide by 2.5. Because that is the inverse of multiply. Because anything divided by itself here, this is going to be a 1x equals. And you actually get a really nice number here, so if you take -20 divided by 2.5, you get a -8. So we went through 2 of these examples. Yes, they are longer. Okay, yes, they are longer. But if you go through those steps each and every time, one step at a time, we can be successful at solving multi-step equations.